Hello everyone, Doug Simonian over at New York Metro Weather with your latest premium free video discussion. We'll be talking about all of the nitty-gritty regarding what exactly is causing the snowstorm that's upcoming from Wednesday night into Thursday, how much snow can we expect, and can there still be changes from here on in. So let's get started by talking about, this is today's European model, valid at 500 millibars, which is about the middle of the atmosphere, and the colors are the vorticity, which represents the counterclockwise spin in the atmosphere, or which is a good vague representation of the amount of energy in the atmosphere. And we can see that as of this evening, we have our disturbance that's moved in from the Pacific into the Pacific Northwest, and it's somewhat strung out, but there is pretty strong vorticity with it. And then we have a second area of vorticity in Canada diving down from a ridge. And as we scroll through time, we can see that this shortwave energy and vorticity dives into the southern plains and amplifies with time. Now, what's also very important is that there is a cold front that swings through with the rainstorm that we currently have ongoing, and that cold front also provides additional fuel for the storm to develop, because what's happening is we're getting perfect timing between the parent shortwave in the southern plains and then the second shortwave digging in from the northern stream in Canada that's phasing. But they aren't phased yet. This is Wednesday evening now. But the pattern is getting more amplified as this trough digs in the eastern half of the country. And when you get a digging trough, you amplify the flow more. So you allow falling low pressures to develop to your southwest and then swing around like a pendulum up through the Tennessee Valley into the mid-Atlantic and up the coast. Previous model runs were a lot flatter overall, and they had more of a general west to east trajectory and not a pendulum, which could still produce a quick hitting snow, but the west to east movement, one, it gathers less moisture from the Gulf, and the west to east movement led to less interaction with the northern stream, so it was basically just a lead wave out ahead of it. But now that the trough has gotten so much deeper, we have more interaction between the parent storm and the northern stream, and more moisture gets sucked into the storm as well. Plus, the fact that they're all interacting right where the frontal boundary crosses means you have a strong temperature gradient as well, which adds even more lift to the atmosphere than what we normally would see with this type of storm. So this is now 1 a.m. Thursday morning. We see the energy is actually starting to phase together in the Tennessee Valley, and the trough continues to dig deep and go on a negative tilt from the Great Lakes through the Carolinas, and the heights along the East Coast rapidly rise. We get a consolidated area of vorticity developing along the East Coast, which is fuel for a rapidly intensifying coastal low pressure that bombs out just off the coast and brings heavy amounts of snow. And the phasing actually gets even more impressive as we head towards Thursday afternoon, and as the storm really bombs out. If we take a look at the European model's precipitation and low pressure, we can see that Wednesday evening we see the low pressure starting to gather in Tennessee Valley. But look at the sharp gradient in the thickness lines. 504 thicknesses in southeast Canada, 552 in southern Virginia. So this gradient is extra fuel for the storm to develop, because if you have lots of winds blowing in from the cold sector, and also southerly winds blowing in from the warm sector, you're allowing the warm air and the cold air to easily mix in together, which creates additional lift for the storm. And then, so as we can see, the storm rapidly develops in Virginia on 1 a.m. on Thursday morning, and then the tucked in 996 millibar low right off the Delmarva, with precipitation exploding in the mid-Atlantic and into the northeast, and that intensifies rapidly off the coast with heavy snow throughout most of the I-95 corridor into New England. And what's also interesting about the European model is that because it takes more of a wider pendulum track, so not really west to east, but more of a diving southeast and then turning up the coast. That allows for more cold air to filter in behind the cold front. And as we can see, look how these winds turn very much north and even northwesterly on Thursday afternoon. That helps bring in a lot more cold air than some of the other model runs. And when you have a lot of cold air being brought into the system, that can increase your snow to liquid ratio. So what would initially be maybe even rain or very wet, dense snow would actually transition to more in the way of a fluffier snow that accumulates more efficiently. So you might get maybe 0.6 of an inch of total liquid precipitation as snow, but the ratio may not be 10 to 1, it may be 15 to 1. So you multiply 0.6 by 15 and you get 9 inches of snow. So something like that is very much possible based on the European guidance. And look how much the low bombs out off the coast, sub 980 millibars east of Massachusetts. Now let's take a look at the GFS. It does pretty similar evolution to the European model, a little bit faster with Storm, not as much in the way of digging or the pendulum look as the European had. However, there still is very much in the way of good interaction between the parent shortwave in the Tennessee Valley and the northern stream shortwave traversing the northern tier of the U.S. And they interact, and you get a deep trough, deep negatively tilted trough with a lot of vorticity at the base of the trough and riding up the east coast for a strong coastal low pressure system with snow. And the surface on the GFS shows the same, low pressure developing in Virginia and then intensifying off the coast with heavy snow developing in the northern mid-Atlantic up through our area and into New England as well. So if the European model is right and you account for the ratios actually, that would actually give most of the area around a foot or even more of snow. That may be a little bit extreme, but it does show that the potential is there. The GFS is a little bit less, more along the lines of 8 to 12 inches for the area, which is actually what our current forecast is. Just to talk about the trends a little bit more regarding the storms and the interaction with the northern stream and how much the trough is digging. This is an animation of the last 12 runs of the GFS model valid for 7 a.m. Thursday morning. Look how much deeper the trough gets every run as we move forward in time. So that goes to show the model kept correcting towards having a stronger disturbance at the base of the trough, a deeper trough, and a deeper northern stream. So all these these features are strengthening and phasing together in a very tight temperature gradient, and that really gives the impetus for a large snowstorm developing and a pendulum classic East Coast look where the trough digs in the Tennessee Valley and then the heights rise along the east where the low pressure can really take off. Here's another piece of guidance. This is the SREF short range ensemble forecast. This is the mean of the short range ensemble forecast. It shows a low pressure 993 millibars off the coast with moderate to heavy precipitation from Thursday morning into Thursday afternoon. But what's more interesting is this is the mean low pressure and this is the spread. The fact that there's so much spread shaded to the north of the low pressure means that there are a lot of low pressures that are stronger and just north of the mean, which is very impressive considering the storm is less than 2 days away. And the fact that there are so many ensemble members still to the north and much stronger than the mean goes to show you that we really have a good chance of having a tucked in bombing low pressure right off the coast, which could give some heavy snow to the region. Now let's talk a little bit more about the dynamics specifically. Here's the 18Z 3-kilometer NAM. We see the low pressure. It doesn't take as much of a pendulum look as the European does. It's not really off the coast as much initially. I actually do think the NAM will eventually correct towards the European in that regard somewhat, but maybe not all the way. But as we head toward, this is 8Z Thursday morning, which is 3 a.m., we see the snow is blossoming across PA and continues to get heavier as we move forward in time as the storm strengthens to the south, 994 millibars in central Virginia at 5 a.m. And then forward in time again, we see that the snow keeps getting heavier. And look at this very heavy band of snow on the I-94 corridor just north of DC into Philly and into New Jersey, and that gets stronger as the morning goes on. So if this is right, at 10 a.m. Thursday morning, the New York City area is probably getting in excess of 2 inch per hour snowfall with a 987 millibar low pressure just off the coast. And when you have a rapidly deepening low pressure, that adds to the dynamic cooling of the atmosphere. So, and that's important because initially it could be a little bit warm in some spots, especially in central and southern New Jersey, because we're still going to be cooling off behind the cold front. There's going to be a lag between when the cold front crosses and when the temperatures fall. But when you have a strengthening low pressure to your south, that drags in a lot of northerly winds via counterclockwise flow. And considering how cold the air is just in the north, that's going to very easily drag in cold air from north to south. So even with the low pressure close to you, the fact that it initially went to your south and strengthened it a lot means it can pull in a lot of cold air. And one, adds to the dynamics of the storm, and two, crash the temperatures, which helps increase the snow to liquid ratio and changes any initial rain over to snow, even along the coast, which is why we're confident in a widespread 8 to 12 inches for most of the region. And it would not surprise me at all if those amounts had to go up to maybe in the 12 to 15 inch range as well. Now here's the regular NAM model. This is a 4-panel plot of the surface, 850 millibars, 500 millibars, and one of my favorite things to talk about, the 300 millibar jet streak. So we can see that the surface low pressure is strong in the regular NAM as well. Sub with 1,000 millibars, heavy precipitation overspreading the northern mid-Atlantic. Vorticity is spreading into the area as well, and we have a very tight temperature gradient at 850 millibars, and the strongest of the gradient is right over our area. But look at this jet streak, over 130 knot jet streak to our north in New England, and we are in what we call the right entrance region of that jet streak. So we're on the quote-unquote right side of where the jet streak starts, and that is often an area where you get enhanced lift for precipitation. So we're in a classic spot for that. Now as we head in towards 7 a.m. Thursday morning, the low pressure strengthens to 999 millibars, and heavy precipitation works its way into the area even more. So look how the winds turn due northerly at the surface. So you're dragging in all that cold air from the north. At 850 millibars, look at this big drop in temperatures. That's dynamic cooling from a rapidly intensifying low pressure system, and we have a closed 850 millibar low right on the coast of New Jersey. So usually just inland from or just northwest of this 850 millibar low is where the heaviest banding of snow occurs. So if this is right, we're getting 2+ inches of snow per hour in northern Jersey into New York City, maybe parts of Long Island, and into Connecticut and southeast New York as well. And the jet streak gets even stronger. And what's even more impressive is the fact that we have a second mini jet streak to our south, and we are in the left exit region of that jet streak, which means you're on the left side of where that jet streak ends. So this is called a dual jet streak. So meaning we're getting enhanced lift from 2 jet streaks at the same time, which is a classic feature in some of our biggest snowstorms. And because of that dual jet streak, the precipitation gets even heavier between 7 a.m. and 10 a.m. with over a ½ inch of liquid equivalent precipitation in that 3-hour period. So that could be 5 to 8 inches in just 3 hours on the NAM model run, with more vorticity bleeding into the area as well. Another feature we like to look at for dynamics is called frontogenesis, which is basically a representation of the temperature gradient and how it's behaving. So frontogenesis is when the temperature gradient is tightening with time, and as we explained before, when you have a stronger temperature gradient, it's easier for the warm air to interact with the cold air, where the warm air lifts into the cold dense air and then condenses into precipitation. So the red contours are frontogenesis at this is 700 millibars. So this is somewhat aloft, but usually right where the snowflakes would be forming. And these values are very high, 24 and 40 of frontogenesis. The unit is kind of a complicated unit, but it just goes to show that we have a lot of frontogenesis for lift and precipitation. And the shading is omega, which is just a general representation of upward vertical motion in that column. So we are very much juxtaposing omega and frontogenesis at the same time at 700 millibars, which leads to a lot of lift for snow. And here is this is the jet streak across the U.S. on the NAM run. And we can see there's a very strong jet streak into the plains that actually sort of adds fuel to the fire as far as amplifying the shortwave at the base of the trough in the Tennessee Valley. And then, of course, we have our jet streaks developing in New England, and the other one that eventually moves up into the mid-Atlantic. And notice how PA is sandwiched between those two jet streaks, and these red contours are upper level divergence. And when winds spread out at the upper levels, that's a byproduct of upward vertical motion underneath that, which is why the jet streaks are so important for snow. And as we move forward now towards 4 a.m. Thursday morning, we see that we are very much still sandwiched between those jet streaks, and that is why the precipitation blossoms with time. And again, on Thursday morning, we are in a classic position where we are sandwiched between these two jet streaks with more lift for precipitation. And one last thing before we wrap things up, here is a forecast sounding for New York City, valid at 7 a.m. Thursday morning. We can see there is a classic veering wind profile with height. So we have northerly winds at the low levels of the atmosphere bringing in a lot of cold air. So notice how at the low levels we are actually well below the 0 degree isotherm. But then as we move upwards towards the mid levels of the atmosphere, the winds rapidly shift towards the southeast and the southwest. So you're actually bringing in some warm and moist air aloft. So you're adding a plethora of moisture and lift aloft because of this veering wind profile into the atmosphere, and that helps to create a lot of lift for precipitation. Also notice these slants, these slanted lines with the temperature and the dew point. This is actually could be somewhat slantwise instability, where you have localized pockets of enhanced lift within the column, and that could create enough in the way of instability for even some thunder snow at times. You see the slantwise instability at 900 millibars, and then again at 750 millibars, and then even again at 700 millibars. So I'm not saying that we're definitely going to see thunder snow. I'm actually not convinced there's enough dynamics for that, but this sounding is actually pretty close to supporting thunder snow. And of course, the temperatures are at all levels of the atmosphere are below the 0 C isotherm, so this would support all snow. So I hope you enjoyed this video and that it explains all the meteorological jargon that we look into for the models. Again, we are expecting a general 8 to 12 inches of snow across the entire region, but there is certainly room for it to trend a little bit snowier, especially if the European guidance is right with the higher snowfall ratios, and thus a 12 to 15 inch range is not out of the question. The reason why this storm isn't even bigger than that is because it's moving pretty quickly. It's not really blocked up too well in the midst of the flow, so it's going to be a relatively quick hitting event. But otherwise, a significant snowstorm is expected. So if you're a snow lover, hope you enjoy the snow, and we'll make sure to keep you updated for the rest of today and tomorrow. All right, so have a good rest of your evening. Take care. We'll talk to you guys soon.